Hey friends, you probably knew that Text Control is a powerful library for document editing and PDF generation, but did you also know that they're a strong supporter of the developer community? And it's part of their mission to build and support a strong community by being present, by listening to users, and by sharing knowledge at conferences across Europe and the United States. If you're heading to a conference soon, maybe check if Text Control will be there. Stop by and say hi. You'll find their full conference calendar at textcontrol.com. That's TEXT control.com. Hey friends, I'm Scott Hanselman. This is another episode of Hansel Minutes. Today I'm chatting with Daniel Temkin. He's the author of the new book, 44 Esolangs. It's a monograph of esoteric programming languages. It's a love letter to weird coding languages. How are you, sir?
I'm doing great, thank you.
There's such precision in your language and in the choice of it is a monograph of esoteric programming languages. I showed it to my wife, and she's like, "What is this? Is this an essay? Is it a love letter?" I said, "No, it's a monograph." She's like, "What's a monograph? How did you? Programming is all about intention, and everything in this book is very intentional. Is the subtitle to your book also equally as intentional?"
Yes, so this is a book that is aimed both at programmers and folks in the art world who I'd like to introduce to the idea of Esolangs. So a lot of the language that I use in the book is aimed more at the art crowd. I feel in general that programmers, if they come across terms that they're not familiar with, they'll look them up or they won't worry about them too much. But some of the technical terminology can be a little bit scary to the art crowd. So I have a lot of stuff in here, a lot of references to conceptual artists who they're familiar with, and using words like monograph to make it clear that this is an art book ultimately.
So if an artist sees this, they're going to already know what monograph is. And while I'm not an artist, I looked it up immediately, and I was like, "Oh, what a lovely and precise word." So is this a coffee table book for artists? We say you're introducing this to artists. Are you trying to create a legitimacy around esoteric languages, or what is the bridge? Am I being introduced to art, or are they being introduced to programming?
Um, I think, the main thing I want to do with this book for both audiences is to show them that there's more happening in Esolangs than simple puzzle languages for programmers and joke languages with kind of silly vocabulary. I feel like Esolangs have, in terms of how they're presented in public, they often fall back at a kind of listicle thinking, where it's like, oh, here's a wacky programming language. Here's another wacky one. But one of them might be writing code in the style of Arnold Schwarzenegger, which doesn't really give a lot of room for exploration. And another one might be creating code in the form of images, like the language Pete. That language allows for individual programmers to bring their own visual style to code and to really sort of stretch the aesthetics of the Pete language and find their own style within it. And it's much richer in terms of the exploration that it does. And so with this book, I'm really hoping to show people that there's more to Esolangs than they might have realized.
So Pete is made by David Morgan Marr, if I recall.
Yes, that's correct. Yes.
Yeah. And is this a large community? Like I can think of 4 or 5 kind of figures in the space of Esolangs, David, Chris Pressey, but it doesn't feel like it's the kind of thing that would fill a Reddit of millions of people. Is that a fair statement?
Yeah, that's true. There are many programmers who are familiar with a few Esolangs. There are many high school and college kids who create one Esolang to sort of first learn how to create an interpreter or a compiler. And I think that alone is something that's very valuable to encourage people to show that they are able to design a programming language of their own. And Esolangs are sort of a more natural place to do that because you can explore kind of a strange idea and it's immediately satisfying, and you don't have to create like a linker for it if you don't want to, because that's not sort of the expectation. But so there are a lot of people who sort of dabble in Esolangs or have created one or two at some point. But the actual community of people who are kind of regularly producing Esolangs is somewhat smaller. And I've interviewed many of them for my blog, Esoteric Codes. So I got into Esolanging kind of like 2007, 2008. And at the time, the documentation was very technical. You can go to the Esolangs wiki, and if you look up one of the most common Esolangs, brainfuck, what does it tell you about this? It tells you the name is offensive to some people. The second thing it tells you is that it starts with a memory block of 30,000 memory cells. These are like the least interesting things about the language. What's interesting about the language is that because there are only 8 commands, you have to translate your algorithm into these very simple steps, which create this great complexity of meaning almost immediately when you jump into the language. And that people have done some sort of amazing things in this language. Someone built a web server that runs in this. It's very slow, but all this stuff is very impressive. So I started Esoteric Codes to talk to other Esolangers in terms of the ideas behind their languages, what languages influence them, what concept were they trying to explore, and trying to keep them away from the highly technical language, which can be confounding to some people and sort of lock some people out of that space because they don't understand. And then in addition, I interviewed digital poets and artists who create work where you have to read the code to fully understand the work. That's sort of my cutoff point. And kind of, but mainly picking people whose work makes sense in conversation with those Esolangs, to try to encourage people to go further with their ideas and create more of a larger community of people coming from these different spaces, the hacker hobbyists, the digital poets, the digital artists, and so on, to bring them into conversation and encourage more work of this kind.
Yeah, I think that you bring up a good point that a lot of us were introduced to these languages. Like I remember learning about Bufunge in like 1993, and it was in the context of a class, and it was a compiler class, and it was about Lex and Yak, and here's a weird language that someone's working on. And it was just it was a kind of a trite acknowledgement that like it doesn't always have to look like English, it can be weird. And it wasn't presented as art, it was almost presented as like, let's see how hard we can make programming, almost like it was to be mean to a point. And there was like, some of these Esolangs are mean spirited, and then they're like, let's see how complicated we can make it and mess with people's heads, like the brain F that you mentioned. But that doesn't feel like art. That's almost like a caricature of a programmer, because in the 90s, there wasn't a lot of inclusion in programming. So it was just like, let's see how hard we can make this. Linux on the desktop, compile your own kernel, blah. And I like things to be more like accessible. So I like the idea that this is an exploration of, who said it needed to be like this? What if it was pretty? And what if it looked like QR codes? And what if it was fun?
Yeah, each of these languages is a creative exploration of some kind. Because we had the language false, and that inspired a number of other languages. And false had commands that were represented with one character. So you have brainfuck, which took that in one direction, and then you have bufunge, which took it in another. That said, once we have commands that are single characters, we don't need to read from left to right if we don't want to. We can read up and down. We can go off the side and come back on the other side, and so on. Let's do something with that. And I guess the impetus behind that was to make something that you could write an interpreter for, but that would be the most difficult language to design a compiler for. And so that's really interesting. But then on top of that, then you have Pete coming later, where the flow similarly kind of turns in different directions, but now we're working with color instead of with characters. So I think that's really indebted to Bufunge as well, both are stack languages as well. So you can kind of see how each language sort of inspires the next, and they are exploring these sort of less explored spaces of and possibilities of language design.
Now, there's 44 Esolangs in this book. Are all of them realized and we can go and get clone, or are some of them theoretical, they could exist, and the rest is left as an exercise to the reader languages?
Yeah, so these are languages that each kind of in some way challenge conventional ideas of what a programming language is, or what it's for, or who it's for. And in some cases, it means that it's going to lead to languages that are not realizable in any form. They can't really be implemented. That could be because the language has a logical contradiction in its definition. It could be that there's no real point in implementing it because reading the prompt is enough to give you the idea of what the language is. And some are really just left for the reader to sort of have um, their own take on. So I think a lot about there's this differentiation by Solowit, the conceptual artist, between the concept of a work and the idea of a work. The concept of a work is somewhat hand wavy. It's sort of the initial. It's the initial concept. It doesn't have all the details filled in, but it gives what the flavor of the work is and what the work is about. But then the idea fills in all the details, and it still doesn't mean that the thing becomes a physical object. It could still just be an idea alone, but it has the details filled in that now it's much more specific. And that's really what I wanted out of the realization is filling in all those details, because often it's surprising. The decisions made in that prompt can lead to things in the realization that are sort of unexpected, but are sort of inevitable because of what's defined in the prompt itself. So the way the book is set up, you read all the prompts first without necessarily knowing which ones have been implemented or not, and then when you get to the second half of the book, you can see which ones were actually designed.
Yeah, and I have to admit that took me aback a bit, because I was going through the book and I get around to page 20 and then it says prompts, and I worry that word prompts has been ruined by the AI bros, because I read them. Unfortunately, the word prompt has been co-opted, and I read them as prompts that I would fit into a GPT. But much of this work was done long before we had that word ruined. These aren't prompts to be fed into a chatbot. These are pitches. Like pitch me an Esolang. Okay, here's an idea. Do this. It's a language, except it's musical notes. It's a pitch, but prompt is the correct word. You just had it stolen from you, the word.
Yeah, it's really strange how much the book feels in parts like it's about AI, that it's a comment on AI and sort of a reaction to it, because it really was written before vibe coding was really a thing, and certainly before I was doing any code generation with AI. And the prompts, if you feed these prompts to an AI system, you're going to get the most boring answer possible, right?
Yes, the statistically most mediocre answer that they can give you.
And this is something that I've actually tried with students. And one of the things that I really try to get across to them is don't leave any creative decisions to AI. Use AI to build to generate code, but you have to be specific about what you want. If you're letting it make any sort of creative decision, so there's a well-known Esolang called Shakespeare, which I don't particularly enjoy. I don't think it's particularly funny, but it's written as dialogue, as Shakespearean dialogue, and I think compliments add a number and insults subtract them, so you get these long strings of insults. And it gets very sort of repetitive. One of the languages in this book is about code written as affect, as feeling that goes beyond words. And it was designed as a prompt that could never really be implemented. Of course, we can invoke certain feelings through poetry or through art, but the idea that we could encode that into code somehow, and that this would be sort of readable to somebody, seems pretty far-fetched. But it's something interesting to think about. So we did feed this into an AI prompt. I think it was Claude. And it basically generated a version of Shakespeare. It's sort of like what it took as being affect or feeling are sort of positive words and negative words. So we sort of recreated this other Esolang with sort of the least interesting response to that prompt.
Which makes a lot of sense if we think about the corpus in which these things are trained, and that Shakespeare already exists as an Esolang and is inside the AI somewhere. It's reasonable that it would kind of find the statistical mean and go, there's prior art there. And it would not, by definition, be creative, which explains a lot.
Yeah, absolutely.
Yeah. The part that I'm struggling with, and I think it might be the one half of the brain versus I felt my brain, the right half versus the left half, the artistic half versus the analytical half, kind of fighting each other, because I wonder which parts of my brain are on when I am coding versus which parts of my brain are on when I am appreciating art or visiting a museum. And I felt like my hemispheres were fighting, because part of my brain was going into like well, actually, this is not Turing complete, and then the other half was like, oh, wow, that is fun and interesting. And I am challenged by that idea. Like there was one that I thought was really extraordinary, which was what if you just used empty folder structures to present a programming language? The idea that the file structure itself has enough context and there's enough to play with from empty folders and file names and their structure within the file names and whether or not this is hierarchical, scoping through files. It's so kind of like ridiculous that it almost flipped the odometer in my brain from this is ridiculous to like, this is actually a really clever way to use the file system as a database. And the hemispheres are fighting it out the whole time.
Well, I'll tell you about the inspiration for that. So for 12 folders is a Turing complete language.
Is it? That's
not all
crazy.
Not all the languages in here are, but that one is. So the idea of folders is that the inspiration for it was the Esolang white space, where we use tab, space, and return as the only meaningful characters. And I decided, well, those are still characters. There's still a file. What's more empty than an empty-looking file? And to me, that was really the empty folder, or the folder that just has other folders in it, because it always just looks like trash. Like this is. So the way that folders works, the names of the folders don't matter except for how they're read alphabetically. And the top level folders are commands, and then the first folder alphabetically in each one, the number of folders in that tells you what kind of command it is, and then a second folder will be an expression that's passed to it depending on the type of command. So this is usable. This is workable. One of the things about folders is that I originally wrote it with a C# compiler, and this was probably around 10 years ago. So I originally made it sort of Windows only. This was sort of like that era of C#. And the funny thing about Windows is that it doesn't consider an empty folder content. So if you create 1 billion folders and you get info on it, it'll tell you that it takes up 0 bytes on disk. Of course, your hard drive will get smaller and smaller as you add more billions of folders and so on. But one kind of nice thing about the folders programming language is that the input and output are through folder names. And all the temporary storage is stored as strings and folder names as well. So you can have basically a parallel file system where all your data is just stored as folders, and you just get free infinite storage.
And I was also thinking how quickly it would take now in the world of Dropbox and OneDrive. How long would it take you to break OneDrive, effectively DDoSing OneDrive with a hello world that takes 350,000 folders, taking up no storage, but certainly taking up a huge amount of time in syncing. And then also the fact that you have to URL encode certain characters that the folders don't allow. So you're in fact tunneling additional information in the folder names that isn't allowed by virtue of how Windows deals with its file systems.
True. Well, that sounds like a challenge. Let's break it.
And this is the thing, right? Let's go and break OneDrive and Dropbox by synchronizing 1 million folders up into the cloud. And you did that like 10 years ago. This is worth noting that esoteric.codes and this book is not something that you banged out in a year. This is your life's work in a sense of art that you have explored over time. How do these ideas come to you, though? Are you just sitting around one day in 2015 and you're like, white space is cool, but folders, that's way cooler. Like, does this just come to you in the shower?
Yeah, generally one language leads to the next. A lot of them are about kind of the constraints of programming languages and how we can sort of push at the outer edges of it. So one way to think about a program is as a performance score, right? It's a score for the computer to perform. There's a long history of performance scores in conceptual art and in Fluxus and other visual art, such that we can consider things like performances that only are imagined, that can only run in our head. And there are several languages like that in the book. Ones that will only make sense to one person at a time and won't be meaningful to other people. But I guess another way to look at this is a programming language tells us what code is, right? A programming language defines the lexicon and grammar of code. Like that seems sort of obvious, but it also presents an abstract version of the machine. And that's where the logic of the language is defined. So it's really the programming language that defines everything else. And what would happen if we sort of unmoor that from not just practicality, but from our physical machines? And we sort of lift the whole thing out into space, and we just think about the programming language alone, and what can we do with this? How can we push it at the edges of what we consider code, of what we consider a machine, of what's performable? And so that's a lot of the thinking that I do when I'm designing these languages. So, for instance, I have a language in the book called past tense. And past tense is just literally, we take a program that runs in another language and we convert any text in it that can be verbed into a verb, and then we convert that verb in the past tense. And now it is no longer a running program because it can no longer run in its original language. So we might start with, public static string hello world, and we'll end up with public static strung, for one thing, classed namespaced helloed world.
Oh, I see. Okay. Public static voided mained strong.
Exactly. Yeah. So now it is, so now we have our text. This is a valid program in past tense. But there's no runability in past tense, because the whole idea of past tense is that program is now in the past tense and should never be run again. So if you were to actually write a compiler for past tense C, then those programs would no longer be valid as past tense, because now they are runnable. They've been brought back into the present in a way that sort of violates the rules of the past tense language.
The one of the ones that really struck me, I would say my favorite, is language 33 called Stroll. It made me think about like spy movies and things like Sneakers and some of the classic movies of the 90s, and how cool it would be if someone had encoded a programming language that required human beings to wander around a city or a town in order to get the program. Help me understand what Stroll is and why it requires 3 pedestrians and their routes in order to realize instructions you would feed into a computer.
Yeah. So the red stroller and the green stroller, they each have their own way of moving through the space. The red stroller is going from intersection to intersection, and the green stroller from block to block. And the green stroller is pointing to a space in memory that's represented by that block. And based on what the red stroller and the blue stroller do, data can be written to that block or read from it. So the red stroller is in charge of all the constants, and those are really defined by the street names at each intersection. But the most critical stroller is the blue one. And the main thing about the blue one is that the way that their code is read is unique to that person, and they can define it themselves in a way that might be totally different than another stroll program. The only critical thing about it is that it has to be something that you can only learn by being there in person. If it's something that you can easily find out by looking at photos and looking at Google Maps, then it shouldn't be used for this. And so it requires a human being to sort of make decisions and sort of interpret what the previous blue stroller has set out. It could be things like the species of various trees along blocks. It can be about the incline of the street. Sometimes it can be something like the number of windows, but you have to be careful with that, of course, because all this stuff is online now. And so part of what makes it a stroll program is that if you start the whole thing from the wrong intersection or in another town, it'll have a completely different result. It's a site-specific language.
Yeah. It's site-specific. It's ephemeral. It might be different. You run it on Saturday and it's different. Someone fills a pothole in or chops a tree down, and then suddenly this thing doesn't work at all, or you're going to have to change the structure.
Yeah, absolutely. And a lot of that's built in. I mean, usually when we write code, we want the computer to carry things out the way that we expect. But a lot of the languages in this book sort of undermine that in some way. They're about sort of they're saying that oftentimes code is more interesting when it does something that we're not expecting and not exactly what we had desired. It might bring us somewhere different. And so a lot of these languages approach code without that feeling of absolute control that we pretend to have when we write code.
I've had a couple of people on the podcast in the past that have created programs in non-English languages. I saw that there are some here that use glyphs that custom make their own. You've custom made your own glyphs. It looks kind of like Stargate. I think one of them was called Thermo C, which like almost like a Wingdings style of a thing. Have you spent any other time looking at non-English languages? Just I'm curious. I know it's not in the book, and you haven't explored it in the book, but I'm curious if you've explored languages that are in non-English, like Arabic or Amharic.
Yes. So there are a few reasons that people make programming languages that are in languages other than English. The most common are that they want something they build as an educational language for a community that perhaps, like especially for children who might not yet be comfortable with English, or to sort of encourage communication in another language. But then there are languages that are made to specifically challenge English as the dominant language of coding. And some of those really fall more in the esoteric category because they're made more, they're not made for the practical use as much as to make a statement. The most well-known of these is a language called Alb or Kalb by Ramsey Nasser. And that was a Lisp language made in Arabic, which had started out to be a useful tool. And then what he found was that he was prevented from going as far as he wanted to with the language because a lot of the underlying technology had these biases that became very obvious when he was trying to work with a right to left language. And also it raised questions like, what's the Arabic translation of proxy bean or these other sort of technical terms, and how do you even deal with that in another language? Now, that language became pretty well known and it has inspired a whole bunch of languages in response. There's a language called Yorlang, Y-O-R-Lang, which is in Yoruba, which was made by a Nigerian programmer who spent all day speaking English for his day job. And after hours, he didn't want to think about English at all. So he wanted to code in his native tongue. And then there's a language called Cree Sharp, which is a multimedia storytelling language using the Canadian Aboriginal syntax characters. And that's by John Corbett, who actually is the person who I am collaborating on for that language that you mentioned from the book, the one that has like the really sort of crazy characters. This is one that we're really right in the middle of designing right now. And the idea of that language is that each line of code is a single character, and that one character has different kind of swoops and ascenders and descenders and crosses, and each of them adds to the meaning of that line of code. But the code is that the line of code is essentially it has a subject and an adjunct. The subject goes through a test, and if the test succeeds, it is transformed in some way. So the subject is basically a variable, and there's basically some kind of conditional. And if the conditional passes, then the subject is transformed, and it can be in terms of the adjunct, which is essentially a parameter that comes in. And if you want to do something more sophisticated, you have to go to like currying and do something. You have to get a little bit fancier. But the idea is that the character is pronounceable based on how the letter is drawn, and the way the letter is drawn is also controls how it runs as code. And we have our own font for that, which we're in the middle of designing at the moment.
It might be counter to your goals, but I think it might be worth at least me asking whether it be something like one of the 44 Esolangs in the book or something like your language self-identifies as an esoteric programming language. Would we ever want one of them to graduate, for lack of a better word? Like your lang, the Yoruba one that you mentioned, is expressly in the first line when you visit their website, it says, is an esoteric programming language, as opposed to saying is a programming language. Now, I've always said that English isn't the language that we deserve. It's just the one that we have. It's the big colonized language. And I feel the same way about JavaScript. Like the world could have deserved a better language, but JavaScript is the one that we ended up with, right? Do you think that any of these could be real in the mainstream sense, or by definition they can't be? They can't graduate beyond esoteric.
Yeah, so I think that Erlang is a great example of one where the performance of the code is very clear from the text of code, so long as you read Yoruba. So it doesn't have that feature that we associate with Esolangs of being obfuscatory or difficult to read in a way that sort of prevents it from mainstream use. I think that Yoruba is great to use for mainstream use. It's not going to have the support that you'll have if you're writing in C#, but it's the beginning of something. And if somebody wanted to push that further, I think that's an example of an Esseling that could be used in mainstream code.
What was the word that you just said? I didn't know. Plascatory?
Oh, I was saying, sorry, I wasn't enunciating very well. I was saying obfuscatory, like obfuscated.
Oh, like to obfuscate.
Yes.
I see. To go out of its way to be obfuscated. Yeah, that's the thing. Like when we talk about like Befunge and the other ones like that, where it's like, this is just mean. Like, it's like, let's just make it hard. This is not what these are about. They're about exploring new spaces, thinking about ways in an unusual way. No one ever, I think, when they made a computer thought like, oh, what if we made this as difficult as possible or as esoteric as possible? Which brings me kind of to my last question. What was the first identified Esolang? Who's the person who said, let's think outside the box first?
The first language that's generally considered an Esolang now, and whose authors consider it an Esolang, would be Intercal from 1972. Intercal is an interesting language because it's a parody of languages of its time, but it still holds a lot of power in how it sort of comments on the experience of coding. It certainly makes coding difficult. So one of the famous features of Intercal is the please operator. If you don't say please enough, it finds you rude and ignores your entire program. But if you say please too much, then it finds you simpering and it also just ignores the entire program. And in the original version, it was not documented how much please you had to use. And so Intercal, I interviewed Don Wood for Esoteric Codes, and actually Don just recently found the long lost code for the original Intercal compiler, which we were very happy to put online earlier this year.
It's so funny. I just wanted to call out that Intercal, which is pronounced and abbreviated Intercal, the full name for the compiler is Compiler Language with No Pronounceable Acronym.
Yeah, I'd forgotten that.
Of course, you call that Intercal. I'm sorry, you were saying.
Yeah, so language one in the book, which is actually the second language, is called Olympus, and Olympus was inspired in part by Intercal. The idea was if you can have this interpreter that has this personality, what if we had 8 of them? What if we had the Greek gods, and each one of them might get sort of annoyed with you and ignore the entire program? Each one of them might ask different things of you in order to make the code runnable. And so I constructed that language in such a way where if you want to do structural things, you have to pray to Zeus or Athena. But if you want to close a block of code, instead of doing it with a right curly bracket, you call on Hades to collect the souls of any variables that remain to live on in his netherworld. And one of the things about this is you have to give the god proper praise, and it has to be commensurate with what you're asking of them, what the complexity of that line of code is. And if you piss off Zeus, he's just going to ignore you for the rest of the program. But the other gods will still keep doing the work. So you'll get this thing where every few lines of code will run and some won't, and so on. And it's actually something you can take advantage of if you wanted to, although I'm not really sure why, what the strategy would be exactly. But all that was really inspired by Intercal.
That definitely brings the demo gods that I seem to always fail to worship. Then my demos fail or my presentations fail to the next level. So the book is 44 Esolangs. You can get it at danieltemkin.com. It's available at Amazon and everywhere that you can find books. You're also on a speaking tour of sorts. I think you're going to. You were just in Portland, Oregon, where I'm at.
I'm going to be there.
Oh, you're going to be there
yet.
Oh,
yeah.
It's October. Yeah, you're going to be at the PDX Hackerspace in a couple of weeks. So I'm in Portland. I'll come and check you out. You're going to be up in Seattle as well. So folks should take a look at danieltemkin.com/esolangs for upcoming speaking dates, some of the press that you've been doing on the book. And you can, again, pick that up anywhere that you get books. It's from MIT Press. Thank you so much, Daniel Temkin, for chatting with me today.
Thank you.
This has been another episode of Hansel Minutes, and we'll see you again next week.